All right. Determine whether the speed of the car is below the maximum speed allowed. Well, let's figure it out, right? Okay, so does it look like they maybe just want you to plug numbers into a formula? Right, so the change in frequency is 2 times whatever frequency it is times V over C, right? Do you suppose they want us to plug in 40 gigahertz for that? 9.5 kilohertz for this? Speed of light for that, and solve for this, right? Keep in mind giga is times 10 to the ninth. These are all in your data packet, so if you forget what giga is, it's there. It's in the front section, okay? Kilo is times 10 to the third, okay? So just be careful of that. Maximum speed allowed is that, right? So you'll calculate it and you'll figure out what their speed is. Just plug the numbers in, right? Okay. And then the next part here says airports use radar. This is a Rayleigh criterion thing, right? So our angle that we can resolve is 1.22 times lambda divided by the aperture, right? And so the diameter of this thing is going to be that, right? Wavelength of the radar is that. And then you could figure out the wavelength, right? Okay. Now, once you have the wavelength, then the question is what distance can be resolved in this, we've done some of these problems, right? Remember that if you have some angle like this, okay, whatever that distance is, I'll call this R, right? That angle is going to be S over R. R is, 31 kilometers, right? So that's 31 times 10 to the third meters, right? Theta is what you got from this. S is going to be what the answer is, okay? All right.